Let's use the knapsack problem to optimize a solution. Let's go.
Hey there guys, so in this video we're going to be talking about computational models. So we have the following computational models, and these computational models help us understand the world which we live in. So experimental devices that help us to understand something that we can predict the future of, etc. So in computational models, what we can do is we have three types of models. So we got two types. One are optimization models. Then we have statistical models. And then last we got simulation models. So we'll be looking at each one throughout the course. So an optimization model is the first thing that we're going to be talking about, and it's based on optimizing a problem set. So if we have a problem, let's say we got a random problem of x, and then it can be solved in a time of t1. So where t1 and we have t2, where t2 is less than t1. And in this case, we have the same problem which can be solved in time t2 by another problem set. So it would be better, which would be better case? It would be t2 since it has less time. So that's how we decide optimization. Suppose we got two areas, A, and we got the destination of B. So we can go from A to B in a straight linear fashion. We just take time t1, or I can go to C and then it can go to B, which takes time t2 and t3, with the total time of t4 is equal to t2 plus t3. So which would be better? T1 obviously, since it's an optimized problem. Why? It has a certain constraint, time. What's the constraint of this? It's time. Then it has a certain fixed limit. It has its source, it has a destination. So that's how we actually decide these optimization problems. So we are going to be talking about the knapsack problem, which is going to be the first problem which we actually discuss optimizations. So the knapsack problem, very interesting problem actually. Suppose, let's say, we got a bag. So in this bag, I'm just going to draw something which I can. Just trying, it looks weird, I know. Okay, anyway. So in this bag, we got several items. We got, let's say, several items ranging from 1, 2, 3, 4, 5, 6, 9. So 9 items, I say. So in these 9 items, we can say that each one has a particular weight, W1, W2, so on, W9. And these each has a value of, let's say, V is equal to 1, 2, and so on, in this case 9. So in this case, we want the bag to carry no more than a weight W. So we have a total weight of less than W, and where V, the value in this case, is maximum. So we're going to have to decide what are the items which we should take and what items are not worth it to take. So we can only take a few. Okay, so how do we decide this? Well, in order to solve this equation, what we're going to do is we're going to say a value and a particular weight pair, which we're going to be considering. And in this case, we're going to be actually having two vectors. One is going to be L, another is going to be V. So L contains all of the elements in the vector. It has 1, 2, so on, 9. And V, let's say I, let's take the parameter of I, and we have V of I is basically 0, 1, 0, 1. It has only binary digits. So what does 0, 1 actually entail? 0 entails the item is not being taken, and 1 means it is being taken. So if we say that the first item is 0, that means we're not taking the first item. The second item of V is 1, that means we are taking the second item, and so on. Third, we're not taking it. So that's how you get it. So what we actually need to find is we're going to have to find V that maximizes sigma and minus 1. What is the case where I is equal to 0? And that is V of I into L of I dot value. Remember that if V of I is 0, then it automatically gets to 0. So we're going to have to define this equation. We want this to be the maximum limit in this case. So how do we go and define that? Well, what we can do is we can say sigma and minus 1, I is equal to 0. We can say V of I times I dot weight less than W. This is another case in which we have to satisfy. It should not be more less than W. It should have the maximum weight. V max weight is less than that. So what would be a brute force method in this case? A brute force method is basically a naive method, that is going straight for the win. So that would be considering all the possibilities and forming subsets of subsets. So if you have 1 to 9, we would have subsets, and then we have another subset considering all the possibilities, permutations of such, combinations of all the elements. And then we would say the following power sets which actually exceed W are going to be nullified or cancelled, and whatever actually is less than W are going to be considered. Well, that would be the brute force method. So from the remaining combination, we would select one. So this brute force method is often not that practical, because we're going to have to do each different iteration. This is a time-wasting process. So guys, can you think of a better way? Well, you know what I would do? Well, the best solution in this case would be an obvious rational human being would actually choose, let's take the most valuable item first. Let's sort all the items based on value. So we have all the items from highest to lowest value. And then we can go and actually consider this. But would this be the best case? Because if we say we have the following value from 8, we have 6, we got 5, 4, 3, 2, 1, and this has a weight of 10. This has a weight of 4, 3, 2, 1, and this has 7, this has 9, this has 6. What would be better here? Because if you're going to take this and the maximum weight is 10 in this case, we would get a total value of 8. It's satisfied. But let's consider this. If you take all 3 of these, that's 4 plus 3 plus 2, and that is 9. And then what's the total value? That's 11 plus 5, that's 15. Then all of them did fail. So what you can learn from this is brute force is not the best method. There's always another way. So guys, the better solution, what we can do is, let's change this up. So the highest value by the unit of weight would give us the best possible solution. That means for each unit of weight, which gives us the highest value? 1 unit of weight, highest value. We're going to be considering these elements. So that's the basic optimized solution for this.
Hey guys, I hope you learned something out of this video. If you like the videos and if you want to watch more or want to learn about a specific topic, leave it in the comments below. If not, just give it a thumbs up and subscribe.